In the sign industry, we usually ask, how much per inch? But this traditional way of quoting does not work for 3D printed letters. Why? Let's make a comparison to understand this. Traditional process, cost is mainly based on 2D area and sheet thickness. Processes such as cutting, bending, and welding are similar regardless of stroke thickness, and materials are calculated based on full sheets. Price formula, height price per inch. 3D printing process, cost is based on the volume of the 3D model, which is finally converted to weight. Two letters of the same 12-inch height, one complex and the other simple different wall thickness, can differ in weight several times, so the cost varies greatly. Pricing rule, weight material unit price. In short, with traditional methods, you pay for a sheet of material. With 3D printing, you pay for every gram actually used. We have made one point clear: the cost of 3D printing essentially depends on material weight, and we usually calculate material weight in grams g. Once the weight is determined, the price is determined. First, let's look at the cross-sectional area. The nozzle extrudes material with width and height. With these, there must be a cross-sectional area, so we can calculate the volume. In actual printing, the filament extruded by the nozzle is flat. For easier calculation, its cross-sectional area is usually approximated as a rectangle. Formula: filament width multiplied by layer height. For example, filament width 0.4 mm, layer height 0.2 mm, so the area is 0.08 square millimeter. From cross-sectional area back to gram weight. Weight equals material density multiplied by cross-sectional area multiplied by print length. Now, let's do a test calculation. First, we generate the model into D to 3D software. At this step, we set different wall thicknesses based on usage scenarios. For example, indoor letter shells can use a relatively thin wall thickness. After input, the software will generate it automatically. For outdoor letter shells, the wall thickness is usually made thicker to ensure strength and weather resistance. The thicker the wall, the stronger the structure, but the more material used. Now we import the two models into slicing software. After slicing, we can quickly see material consumption. With a wall thickness of 1.2 mm, after clicking slice, the software will automatically calculate the print time and material consumption based on the model structure and wall thickness settings. 286.03 grams. Now import the outdoor model we just created. Wall thickness 2.4 mm, material consumption 345.12 grams. Finally, we calculate with the formula: indoor material 100 kg, outdoor 150 kg. Enter the weight, and you'll see the cost directly. Understanding the difference between traditional and 3D printing quotes, you'll find 3D printing pricing much more straightforward. In 3D printing, we don't quote by inch, it only shows letter height. We price accurately by weight. The thickness, complexity of the 3D model directly affect material usage, making pricing fairer and more transparent.